question number one, you can see question number one. What the question number one is saying?
Calculate the amount of CO2 that will be produced when 1 mole of carbon is burnt in air. One mole
Okay,
of
good,
carbon.
good, good. I got the question. You are saying that is calculate uh, amount of CO2 that would be produced. They are talking about that would be produced.
Yeah.
Okay, this question is with you.
Mm-hmm.
Now the A number, they are saying 1 mole of Cu carbon is burnt in air. है ना? 1 mole they are talking about 1 mole carbon is burnt in air. Burnt in air. So see this one. So C plus O2, it is going to be that is CO2, because they are saying calculate the amount of CO2 that would be produced. 1 mole of carbon is produced. So here how many? Okay, this is the 1 mole is given. This one is how many mole is given? 1 mole is given. Now, according to, first of all, we are going according to, see, step number one. Step number what is number of mole. So number
Yeah.
of mole is given how much? That is 1. Number of mole is equal to 1 mole carbon. Okay. Now step number 2. Compare with, they are talking about compare with what? Equation. Compared according to equation or compare with equation. So what is equation? 1 mole carbon. They are saying 1 mole carbon gives how many mole CO2? Gives 1 mole CO, 1 mole CO2. How can I say this one? Because here nothing is there means 1, and here nothing is there means 1. Okay. One, according to coefficient stoichiometry, 1 mole carbon giving 1 mole CO2. Yes, yeah, no?
Uh-huh.
Is
Yes.
it okay, Arav?
Yes, yes, sir.
According to balance equation. Now, see the second point. What the second point they are saying? Second point, if you are talking. So second point they are saying, according to available, step number 3. How much available? You know, according to available amount, available mole. So available mole, if you see available mole, so available mole, we are having how many mole? That is given is 1 mole, 1 mole carbon. So that is
Yeah.
1 mole to 1 mole. है ना? 1 mole to
Yeah.
1 mole carbon gives 1 mole CO2. Here is 1 mole is there. So that is according to available 1 mole carbon gives same 1 mole CO2. That is same is there. Okay. So they are asking that amount they are asking. So N is equal to given mass upon what is molar mass. Given mass is nothing but this is the amount, right? So that is
Yeah.
given mass is equal to N into molar mass, right? So number of mole, if you see here, how much mole is there? 1 mole. And giving 1 mole CO2, then move CO2. For CO2 they are asking. So here I am mentioning 1. What about the molar mass of CO2? Can you guess molar mass of CO2? mm of CO2. Of CO2. Can you guess how much?
77.5. 77.5.
Carbon is 12 atom,
Oh,
oxygen is
12.
16. So 2
16. So
oxygen are there, 1 carbon. So how much will come?
44. 44.
44. Thank you. So the amount is coming how much? Aram 44 gram. A 40 gram CO2 produced.
Yeah.
Are you be able to understand this one?
Yeah. I just got confused with the air, so I was thinking that it would have different.
Steps. If you yeah. Once you miss the steps na, so that will be the problem. Okay. Steps is compulsory required. Step is compulsory required. You must know the steps.
Hmm.
Got it?
Yeah.
Okay, okay. Can I do the next one?
Yeah.
Not visible, I think. Something happened. What I did, something I did.
Okay.
Oh. I did something. Choose background. No. I did something here. Is the screen is visible to you?
Yeah.
whatever I wrote, that is all is visible now.
Yeah. Yes, sir.
Okay, I'm removing this one. Then going for the next question. Can you try the next question, or should I do?
I want to try this one, sir.
Okay, the second one. One mole carbon is burned in
Yeah.
16 gram of O2. See, this is based on the second one is based on the
Yeah.
limiting reagent LR. Second one is based on the limiting reagent. Okay.
Yeah.
Will you do? Can I do? If you allow
Can
me,
I
I will do.
try?
Okay, try. Yeah. Which is limiting reagent in this one? Carbon or oxygen?
This one.
Hmm.
This one limiting region 1/12, 1/16.
You went. You went for the tour now, so you forgot so many things. See, the number of mole we have calculated here is giving 1 mole. This is 0.5 mole, right? So, what is happening? If you are dividing by coefficient, you will get the ratio. And least ratio is going to be our limiting reagent. So that is 1 by 1. So that is 1. Here is 0.5 because here the coefficient is 1. Na? This is also. So 0.5 by 1. So it is going to be 0.5. This is the least value. Yes, yeah, no? Least value. And least value implies that it is the limiting reagent. Got it?
Yeah.
So in spite of using the carbon, we will use which one we have to use. Now we have to use the oxygen because the carbon oxygen is limited. So oxygen will limit the product formation. Yes, yeah, no?
Yeah. So
Tell me.
0.5 O2, 0.5 mole O2 gives 1 mole CO2.
According to equation, go firstly according to equation. That is what you are correctly saying. 1 mole O2 gives how much? 1 mole CO2. That you are saying 1 mole CO2. Step number 4 you are saying. So 0.5 mole.
Okay.
Gives how much? That is 0.5 mole CO2. Is it okay?
Yeah.
1 mole to 1 mole. So 0.5 mole to 0.5 mole. So now amount. How we calculate the amount, you know, that is N is equal to given mass upon molar mass. Given mass is this is going to be amount. Yes or no? So GM is equal to what is going to be N into MM. So N is how much you can see that is 0.5. Molar mass of CO2 is 44. It is going to be 22 gram.
22, yeah. Okay, I'll try it now.
Is it okay?
Yeah.
Is it okay, Arav?
Yeah, yes, sir.
Hello?
Yeah, sir, can you hear me? Hello?
Arav, audible?
Hello, sir. Sir?
Understood this one.
Yes,
Yes,
sir.
yes.
Sir,
Okay.
you're muted.
So, can I erase this one?
Yes, sir.
Muted? No, not muted.
One of
Audible or not? Not audible. You are saying not audible.
No, I mean, like, I can hear you, but it says you're muted on one of your things. It's fine, it's fine.
Not muted. It's okay. I think it's okay. Now can you solve the third one? Third one.
Yeah, I'll try.
The third person of the question also there. That one can you try?
This one would it be same
What is
as
the third portion is saying? You can see.
Yeah, sir.
Same,
Would it be
same. Thank you. Very good.
same,
This will
right?
be the same.
Yeah.
Same, because the limiting reagent is oxygen only, na, and that is going to be 0.5 mole. So that is okay, correct one. Now, in the next question, although it is handwriting is not good, you may try here, but I have taken directly from the tab only, so it's not too much bright. In 3 mole of ethane, calculate the following number of mole of carbon atom. Okay. Can you see the question number second? Next one.
Yeah.
Hello.
Yeah.
So they are saying that is 3 mole of what is there? 3 mole C2 C2S6 are there. Calculate the following numbers. Number of moles of carbon. So see here are that is firstly you have to go for the according to compound. According to compound. So according to compounds, 1 mole C2H6 contain, according to compound, 1 mole C2H6 contain 2 mole carbon, 2 mole carbon atom, 2 mole carbon atom. You can see 2 mole carbon atom. How can you see? Here is 1 mole C2H6 is there, and this contain how many carbon is there? 2. So 1 mole contain 2 mole carbon. Yes or no?
Yeah.
Therefore, according to questions, now we are going according to questions. What they are saying according to question, 3 mole C2H6 contain.
So
3 mole
6.
C2H6 contain how much? So that is 3 into, so that is 6 mole carbon. 6 mole carbon. Can you understand this one?
Yeah.
Now the next one they are saying, number of molecules of hydrogen atom. Okay, number of moles of hydrogen atom. Can you tell me the number of moles of hydrogen? The same way?
18.
18. Thank you. This will be the hydrogen will be what? 18. Hydrogen atom will be how many? 18 mole. 18 mole. Okay. Now the last part they are saying, last part, number of molecules of ethane. See, that is you need to go back to the mole concept. Number of molecules of ethane. How can you do number of molecules of ethane? How can you do this one? Number of molecules of ethane.
I'm checking, sir.
How can you do? So, our number of molecule is equal to what? Number of molecules. So, what is that? Is 1 mole molecules, you know, na? 1 mole molecules, how much? 6.022 into 10 power 23 molecules? Yes.
Yeah.
Yes or no?
Yeah.
So, if it is the n mole molecules, then what will be there? N mole molecules. N mole molecules means n into what? 6.022 into 10 power 23. Yes or no?
Yes.
Yes or no?
Yeah.
So number of molecule is equal to n into what? Na. This is going to be molecules. So here is Na, you know, this formula already we have done so many times. So that is, this is the Avogadro number. N is number of moles. And capital N is number of molecules. Abara, the one thing you see, that is number of mole given in the question, 3 moles. 3 mole ethane. Yes, no? 3 mole ethane.
Yeah.
Yes or no?
Yeah.
So here I am writing 3. Avogadro number you know very well, 6.022 into 10 power 23 molecules. Now you can multiply to get the answer. So 3 2 ja 6, 3 2 ja 6, 0, 3 6 ja 18. So 18.066 into 10 power 23 molecules of C2H6. Molecules of C2H6. Can you understand this one, this problem?
Yeah, I understood, sir.
Thank you. Can I erase this one?
Yeah.
Okay. Now the question number next. Next question number next? They are saying determine the mass of sodium chloride produced when 1.25 mole Cl2 gas react vigorously with the excess sodium. See, 2Na is there, then Cl2 gas is there. It is forming 2NaCl, right? They are saying this is the excess, and Cl2 how much is there? 1.25 mole. So excess means not limiting reagent. Which will be limiting reagent? This is going to be limiting reagent. Yes or no?
Yeah.
Because the question itself is saying that is determine the mass of sodium chloride produced when 1.25 mole Cl gas react with vigorously with excess sodium. So sodium excess. Limited which one? Chlorine is there. So you can see carefully. Step number one. Step number one. Moles you got now moles 1.25. Yes, moles got 1.25. Okay. Now step number two. According to
Mole of
equation,
CO2?
Valence equation. So according to equation, if you are going, how much?
So it's 1.25 is mole of Cl2, right?
It is given now. Moles is already given. 1.25
Okay.
mole Cl2 is given. And this is going to be limiting reagent also. So according to equation, 1 mole Cl2 gives how much? Gives 2 mole NaCl. Is it?
Yeah. No,
Now,
1. Oh no, one. Yeah.
so so they are saying your available is 1.25 mole. So you can write so according to 1.25 mole, according to 1.25 mole Cl2. So how much will give? So 2 into 1.25 mole NaCl, yes or no?
Yeah,
Because
2.5.
one mole, keep in mind, 1 mole to 2 mole. So 1.252 you have to multiply, yes or no? Yes, na?
Huh. Yeah.
So it will going to be 2.50 mole, 2.50 mole NaCl, right? 2.50 mole NaCl. Now amount they are asking, can you calculate amount?
Okay.
Amount. Amount means N is equal to given mass upon molar mass. Okay. So given mass they are asking. So N into what? Molar mass.
What's
Up
any?
sodium is 23 and
20?
Cl is 35.5.
Okay.
So I think it is coming 58.5. Na? Yes or no?
Yeah.
So 2.50 into 58.5. Now solve it. How much is coming? We need to see. Can you do the calculation?
Yeah. 146.25.
Yeah. 146.5 something is coming gram NaCl. So this is going to produce. Now you go through the PDF and check which one is the problematic one that we will discuss here. You go any of the PDF, you can go and see if you are facing the problem, any one that we will solve. Can you go? Can you check the PDF?
Yeah. Check.
Hmm. Any of the problem you can ask, whichever you want.
The next one, the
Hmm.
NH4NO3.
Acha, next one you are asking. Okay,
Yeah.
you can do. I think. Let me again. Let me again
But
see
it's
the question.
the hard part is not the
I
calculation for me. It's to figure out how
uh,
to like uh, Like,
No, that is what I told you. Now, you just imagination is very much important for this one. First of all, that is you have to see the reaction. What is the ratio of the reaction? How much reactant you are taking? Uh, that is why the balancing we are equation balancing now. Otherwise, if you are not matching with the balance equation, what is used to balance? So we have to calculate the number of mole, how much available. Then according to equation, what proportion reactant is there, how proportion product is formed. That is the second step. Third step, how much mole available. So accordingly, it will form. And whatever the balance equation is there, that we have to compare with the according to available mole also. Okay. The third one, you got the available mole. You can convert into the amount. That is the N is equal to given mass upon molar mass. Okay. Let's see. Let's say this question. Uh, I'm telling you, not a very tough question, very easy one. Very, very, very easy. Okay. Little bit initially, I think summer vacation created little bit issue. See, they are saying NH4NO3. NH4NO3 produces what it is producing? H2O plus N2O. H2O plus N2O. Decomposition. Determine the amount of H2O produced when 25 gram NH4NO3 reacted. This one has given 25 gram. So step number one, what we have to do is step number one, Arav. Can you give me any idea? Step number one.
calculate number of moles.
Thank you so much, Arav. Moles. So that is given mass upon molar mass. Given mass is 25. Molar mass, Arav, see, 2 nitrogen are there, so 28.
Yeah.
Four hydrogens are there, so 4. And
Yeah.
3 oxygen are there, so 16 3 ja 48. Yes, yeah, no?
48 plus
Haan.
32. So 80.
32 plus. 80. That is correct. 80. Now we need to calculate in the, it is in the, that is fraction. We need to calculate. Next time I will send you the solve problem. These all having the solution. This I am having the solution of this. I will share you the solve. Here are this is coming 0.3125 mole. This is available, right? Available.
Yeah.
25 gram given in means how many mole available are around? Can you tell me how many mole? That is 0.3125 mole. Yes.
Yeah.
Yes, yeah.
Yes.
Okay. Now, Arav, the second point I am going now is step number two. Step number two. According to equation, according to balance equation. So, according to balance equation, if you are going around, so what is there? One mole NH4NO3 gives how much it is giving around 1 mole H2O. They are asking amount of H2O, na? You can see the amount of H2O. I think they are asking. Calculate the amount of H2O, amount of H2O. So 1 mole NH3 gives 1 mole H2O here. One is there now. No. This is not correct. Hydrogen is 2 here now. Hydrogen is 2. So it will be 2 mole H2O, not 1 mole. You can see this is the equation. I think the equation is not balanced. Equation you see here hydrogen are 4. Hydrogen are 4. So here also will be 4. Na? So 2 mole. In spite of writing 1, you keep in mind the equation is given not balanced equation. 2 mole. 2 mole H2O. Is it okay? Is it okay?
Yeah.
Thank you. Now go for the next one. Next step is step number 3. According to available. According to available. Or see according to available how many? So 1 mole to 2 mole. So 0.3125 mole.
Oh,
No, 3 point mole.
0.05.
Which one is there? We are having mole. And NH4OH gives how much it will give? 2 into 0.3125 mole H2O. Now that we can multiply easily. Okay. How much
0.625.
is there? Let me multiply 2 multiply by 3125. So it is coming out of this is coming 6 point no point is coming 0.625 625 mole
625.
H2O. Now amount you can easily find. So N is equal to given mass upon molar mass. So given mass is equal to, it is going N into mm. So here is how much N how much is there? 0.625 multiplied by molar mass is 18. So if you multiply 11.25 gram, 11.25 gram H2O. Can't you do this one, Arav? Can't you understand this?
Yeah, I got it, sir.
Yeah. Audible?
Yes, sir. Audible.
Okay. Mhm. Now, now see which question you want. Now see which question you want, Arav.
Should I try the next question?
Please. His landscape, how much iron can be theoretically obtained in the reduction of 1 kg Fe2O3? Molar mass of Fe2O3, 160 gram. Yeah, you can try.
Okay.
By the way, I am writing the equation. Fe2O3, it is reducing with the hydrogen, addition of hydrogen. So it is giving 2Fe plus 2Fe it will give plus H2 it will give H2O. So this is not the valence equation. We need to balance this first. Then only we can do. Until or unless we balance, it cannot be
Wait,
helpful.
sir, why would H2? Why would hydrogen?
So how to balance?
Sir.
How to balance, Arav?
Sir, can you hear me?
Hmm.
Yeah,
Can
I'm
we do
asking
three? Can you
why
do
why with hydrogen?
what?
Why with hydrogen?
You can do with anyone then. You can do. You can do any. The answer is going to be same. Answer is going to be same. Can I take another? You can use the Fe2O3 because removal of oxygen is oxidation reduction. Yeah, na?
Okay.
So you are having Fe2O3. You can take the R of C. CO you can take. Better it will be CO. So it is going to give Fe plus. What is that? Is 3CO is there na? So better if you are writing 3CO. So this is going to be CO2. 3CO2. You can balance. Oxygen is 3, carbon is everything is balanced. Anyone you can do. Because the reducing agent is excess. They didn't give any information. So we have to take the given mass of the Fe2O3. And given mass is how much? N mole. I am calculating given mass upon molar mass. Given mass is 1 kg means 1000 gram. Molar mass they are saying 160. Okay. Gram per mole. So the gram will be cancelled out. So here you can try.
Okay.
The audibility is okay now. Or you are facing the problem in audible sound?
No, it's fine. I can hear you, sir.
Is it okay?
Fine. Yes.
Okay. Okay. So see, number of mole, it's divided. 1010 got divided. 50 times 50 upon it is going 8. So it is 25 upon that is going to be 4. So how much is coming? 4 6 ja 24. No. 4 2 ja 8. 4 5 ja 20. 6.25 mole. Is it coming to you for 6.25 mole?
1 second, I'll calculate. Yeah, 6.25.
Yes. Okay. Now the next point we are going. Step number 2. This is the step number 1. What we will do in the step number 2? 1 mole
according to equation.
Fe2O3 gives 2 mole Fe. Are you telling the answer?
I was saying the same thing you just said. And then I said you have to put according to. I said put according to equation, and then you put according to availability.
Yes. Hello.
Hello, sir.
Uh,
Yeah, I was saying first according to equation and then according to availability.
According to available. So is step number 3 we are going step number 3. According to available. So according to available, if you see how much it is coming, I need to see. 1 into 2.
6.5, so 12.5, right?
So this is coming. So that is no. Available is 6 point. How much is there?
6
6.25
point,
now. I
yeah,
was
6,
doing mistake.
12 point,
6.25 available. This is available.
yeah, so 12.5.
12.5.
Yes.
12.5 mole Fe is available. So now amount you can calculate N is equal to given mass upon molar mass. Okay. So that is given mass is equal to N into molar mass of Fe. I know we are talking about Fe. So that is 12.5 multiplied by molar mass of Fe is 56. So you can multiply this one. You will get the answers. It is coming 12.5 multiplied by 56. It is coming 700 gram.
700 gram.
Understood?
Yeah.
Arav?
Yes, sir. Can you hear me?
Okay. Yeah, I am hearing.
Okay. I think
Okay.
my audio is a bit slow to you.
No, everything is. I'm just trying to improve my technology, system.
No, sir, yours is fine. I can hear you properly.
Okay. Arav, what I need to do, you can see that is within 4 minutes, it is going to disconnect.
Yeah.
So I'm giving you the another link. Can I give you another link?
Yeah.